Hello, geometers. This is Miss Backfish, and I am here to go over similar triangles in terms of how we can prove they're similar, the three shortcuts for proving that triangles are similar, excuse me, in this particular notes packet. But first, I just want to go back and do a quick rewind back to what is similarity? What is similar? What does it mean to be similar? Similar figures have the same shape, exactly the same shape, but usually different sizes, not necessarily the same size. Let's say it that way. Technically, if things are congruent, if two figures are congruent, then they're similar. But we'll get into that a little bit more in a second. So basically, similar figures, usually they look like one is an enlargement or a reduction of the other one. Another thing that is always true about similar figures, because they have the same shape, they have congruent angles. And by that, I mean all the angles. All of the angles are congruent. All of the angles, let's put it this way, I'm not saying all of the angles in one shape are congruent to itself. I'm saying all of the corresponding pairs of angles, all of the pairs of corresponding angles are congruent to one another. They have proportional, not congruent, but proportional sides. Okay? All of the side lengths are proportional. What does proportional mean? Well, let's just think about that for a second too. What is a proportion? A proportion is when I take two ratios and compare them and say they're equal to each other. Like 2/3 equals 10/15. That's a proportion. One thing that's always true with a proportion is that the cross product, meaning 10 times 3, the diagonal cross product, go diagonally across, and product means multiply, and the other cross product, 2 times 15, those are always going to be the same. If you have a true proportion, which this is, then 2 times 15, the top on one side times the bottom on the other side, will equal the other top times the other bottom. So 10 times 3. Those are both 30. So that's one way you can check to see if something is a true proportion, but it's also a fact we can use to find missing side lengths. Okay, so this is what it means by proportional. Let me give you an example. These two triangles, I have assigned them side lengths so that the side lengths are proportional. What does that mean? It means the smallest side here and the smallest side here, 2 and 5. That ratio is the same as the ratio of these two sides, 4/10. And that ratio is the same as the ratio of these two sides, 5/12.5. So another way to say this is that when figures are similar, their side length ratio is always the same. If you take two corresponding side lengths and you set up a ratio between them, that's going to be the same no matter which pair of corresponding sides we pick. These have the same ratio as these do, as these do. Okay, how did I know to write the 2 on top? I didn't. That's a choice. I could have said 5/2. As long as I'm consistent. So if I put 5/2, then I would compare that to 10/4. In other words, if I start with the big triangle for the 5/2, I better start with the big triangle for the 10 as well. So 5/2 equals 10/4 equals 12.5/5. This is always true in similar figures, is that the side length ratio is the same for any pair of corresponding sides. And that's why that side length ratio is special. If you take any of these and simplify them, this one's already simplified, you'll get the same thing. You'll get 2/5 for all of those. That is what we call the similarity ratio. Similarity, I'm running out of space, sorry. So the similarity ratio is just the side length ratio written in simplest form. Which side lengths? Well, all of them, because that's the point, is that they would all have the same ratio. So it doesn't matter which pair of corresponding sides I know, the ratio of that pair of corresponding sides would be the same, and it would simplify to be the similarity ratio. Okay, so what this is about is the fact that if I'm looking at triangles, and everything I just talked about before this would be true for non-triangular shapes as well, but this specifically is the fact that we have three shortcuts to knowing things are similar. Remember, if two, or specifically triangles, if you had two triangles and they're similar, all their angles would be congruent and all their side lengths would be proportional. So that's 3 angles, 3 side lengths. That's 6 different things to know. Here, these are shortcuts. I only have to know 2 or 3 things here. We've done the same thing before with triangle congruence. This is different. This is for triangle similarity, but it looks very similar. Oh, no pun intended on similar, but it looks a lot like when we were doing triangle congruence. I will take issue with this. I didn't make this worksheet, but I am going to say I don't think they meant this the way it's coming across a little bit. It says 2 figures are considered to be similar if the 2 figures have the same shape but may differ in size. To be similar by definition, all corresponding sides have the same ratio or all corresponding angles are congruent. Well, I think what they were trying to say is if you know that all corresponding sides have the ratio or you know this, then you know enough. But technically, by definition, both of those are true. Similarity says that both of those things are true. These are just shortcuts to getting that information. So the first one is angle, angle. If 2 angles of one triangle are congruent, so in other words, the same, even though we're not talking about congruent triangles, the angles are still congruent. And it's a little hard to see these markings, but here you have B marked congruent to E, A marked congruent to D. Now the case over here, this example is a great one because it's one that trips people up. If you look at these 2 figures, you're like, okay, I see right angles. Yes, those are congruent. Great. But then I see 43 and I see 47. Oh, those aren't the same. I guess they're not similar. Well, we don't know what the missing angle is. So we need to find one of these 2 angles to find out if maybe it's a 43 over here or a 47 over here. And that's exactly what does happen. In a right triangle, remember the 2 acute angles, the 2 angles that are not right, have to add up to 90. So if I do 90 minus 47, that will give me this angle right here at D. 90 minus 47 gives me 43. So this angle is indeed 43. And now I do know 2 pairs of congruent angles. Angle D here is congruent to angle A, which is also 43. And then angle B is 90 and angle E is 90. So because angle D is congruent to angle A and angle B is congruent to angle E, that is considered angle, angle. And I do know these are similar by AA. The next triangle congruence postulate, or excuse me, not congruence. It's very easy to make that mistake. Similarity, not congruence. Side, side, side. Okay, so we had one of those for congruence too. Here's the difference. We're not talking about sides being all the same. We're talking about them being proportional, not congruent. I got to change colors for that. Proportional in hot pink. They don't have to be the same. They have to be proportional. So for instance, if these are supposed to be similar, if these are indeed similar, that means that, for instance, and I don't know for sure from this one what's the smallest and what's the biggest size, but we're going to take a guess. That means like AB over ED, whatever that ratio is, BC over EF would be the same ratio, and AC over DF would be the same ratio. And that's me just guessing from the way they look. Normally we need more information than that though. So over here we have more information. We can check to see if these 2 triangles are indeed similar. Something to be careful about here. Do not look at them and just be like, I'm going to compare the one on the left to the one on the left. Don't compare based on the position of the figure. If you know all the numbers, go with the numerical values. In other words, look for the smallest side here and only compare it to the smallest side here. Largest side here, compare to the largest side here, and so on. Make sure you're comparing apples to apples and oranges to oranges. So the smallest side in this triangle is 6. I'm going to compare that to the smallest side in this triangle, which is the 10. Okay, and one way of making this comparison is to simplify your fractions, and I'm going to go ahead and do that on this one as I go. 6/10 simplifies to 3/5. Okay. The next pair, I'm going to go medium-sized, 9 here. The medium-sized one here is 15, so 9 to 15. 9 over 15. also simplifies to 3/5. And last, the largest side in this triangle over the largest side in the other triangle, 12 over 20. And 12 over 20 also does simplify to 3/5. That is one way of comparing your fractions, is simplify them, get them all in simplest term. All right, there we go. We know that they're all equal. So yes, I have verified that these two triangles are similar. Yes, by side, side, side. I compared all three pairs of sides and found that they all have the same ratio. All right, I didn't look at any angles. Let me point out, this is again from the sort of intro lesson, this is called a similarity statement. This is another way to know what's supposed to go together, what's supposed to correspond. This is how I know that EF, first two letters here, needs to be compared to LM, first two letters there, and so on. Okay, last one here is side angle side. Again, we had a side angle side for congruence, but again, that was congruent sides. We're looking for proportional sides. What's the same here, though, is it does have to be the included angle, meaning if I'm looking at this side and this side, then the angle where those two sides meet is the angle I'm interested in. That's the included angle. If I'm comparing these two sides, then I'm looking at this angle. So over here, example 3, this is another case of that very common error I told you to watch out for. Let me grab a piece of paper so I can demonstrate it. A lot of students coming upon this problem, maybe rushing through a whole page of problems and not really thinking, would do this. And they would check that. Now, how can you check that? You can simplify it just like I did up here. I can simplify each of the fractions. Another way I can check it, well, remember we said that in a proportion, the cross products always have to give you the same number. Okay, so that means if this is true, then 12 times 16 must be equal to 20 times 15. Spoiler alert, those are not equal. Okay, so again, that hurried, rushing student goes, oh, these are not similar, never mind, that's a no. But here's the problem. 12 doesn't go with 20. 12 is the smallest side in this triangle. 20 is the biggest side in this triangle. 12 goes with 16. That's what I have to compare. Smallest to smallest and compare largest to largest. So this is what I'm comparing and basically asking, are these equal? Well, let's do it the same way we just said we were going to do it, using the property of proportions that the cross products should be equal. So if those two fractions are equal, if those two ratios are the same, then 12 times 20, top of one side times bottom of the other, should give me the same thing as 15 times 16, top of one side times bottom of the other. Yes, they do. Okay, so I'm going to erase my little question mark. They do indeed. I'll put a little check mark. Yes, those are equal. Now, where's my angle? This is supposed to be side angle side. Well, don't forget vertical angles. Vertical angles are always congruent, and the angle is in the right position. It's the included angle for the two sides we're looking at in both triangles. Has to be true in both triangles. So that is the angle right there where the sides meet. So I'm going to say yes, these are similar by side angle side. Now, down here at the bottom, the now you try, let's walk through this. This would be a great time to pause the video and try it yourself. I'm going to go ahead and solve it. If you haven't hit pause, now's the time to do it. All right, triangle ABC is similar to blank because of blank. Well, let's look at the markings here. A has two little arcs, so does D. So D goes with A. B has nothing on it, just like E. And C and F have the same markings. Now, how do I know they're similar? Well, it can't be side lengths, and I'll show you why it can't be side lengths in a second, but it is angle. There's a pair of corresponding angles that are congruent. There's a pair of corresponding angles that are congruent. So that's my reason. That's exactly what these are. These are reasons to be able to say, yes, they are similar. Did I say congruent? Again, catch me if I do that. So these are similar. These are my 3 reasons that I'm allowed to say that 2 triangles are similar. AA, SSS, or SAS. So in this case, it's AA, that triangle ABC is similar to triangle DEF. If we haven't mentioned it, that is the symbol for is similar to. Now, I don't even have to have this drawing to complete number 2 now because I have the similarity statement. Remember, that's what this is called, is the similarity statement. So AB over DE has the same ratio as what goes with EF. Second letter, third letter, second letter, third letter. That'd be BC. And CA, last letter, first letter, last letter, first letter goes with FD. And then over here, we're just filling in what we know about these segments. DE is 12. What's AB? It's X. So I'm going to write an X right here. BC, we already know is 8. EF, that's right down here. We're going to call it Y. And then CA, we already know is 6. FD is 16. Number 3, I'm just going to go ahead and do real quick because it's more about the name. Angle B is congruent, is the second letter, so it's congruent to angle E. Now, for everything else, we're using what we learned here. Remember that the whole point of similarity is that these corresponding sides have the same ratio. They're proportional, which means have the same ratio. So all of these ratios are the same. You can't solve for when you have 3 ratios all at once. Okay, going back to this little picture I keep showing you, a proportion is about 2 ratios. 2/3 is a ratio, 10/15 is a ratio. We set them equal to each other, we have a proportion. So we're only going to solve 2 of these, put these 2 of these together at once to solve. Now, if I were to say, and for instance, let's say I did the first 2 together. All right, we solve by cross multiplying. When I cross multiply, I get x times y equals 8 times 12, which is 96. That hasn't helped me at all. So I'm not going to do this. In order to solve, I need to have only one variable. So I'm going to put the x over 12 with the 6 over 16. You need to find the fraction. You need at least one fraction where you know both the numerator and the denominator so that you know what the ratio of the sides is supposed to be. So x over 12 is supposed to be equal to 6 over 16. Now another option here, you can go ahead and do a proportion, solve your proportion by cross multiplying here, or you're allowed to simplify this because these are both even numbers. The simplified form of 6 over 16 is 3 over 8. And remember, if I know the ratio of any of the corresponding sides and I simplify it, that is my similarity ratio. Now this says scale factor, but honestly, that's what they mean is similarity ratio. A lot of times those terms are used interchangeably. They're technically not exactly the same thing, but they're close enough that we know that's what they meant here. So the similarity ratio is this 6 over 16 reduced. And that's what I'm going to use. I'm going to use the 3 over 8. You could use the 6 over 16, that's fine. And put it equal to this fraction first. And then go back and put 6 over 16 equal to the 8 over y next. I like doing this one just because it's simpler. If I can simplify first, I'm going to do that. So I get 8 times x when I do this cross product. And the other cross product is 12 times 3. So those have to be equal. That's always true with a proportion is the cross products are equal. And this gives me 4.5. If you wanted it as a simplified fraction, that would be 9 over 2. Okay, so that's the answer for x. Next, we're going to find y. So I'm going to put 6 over 16, or might as well use 3 over 8 equals 8 over y. All of these ratios have to be the same. That's what it means to be similar. So I'm going to do Cross product here, 3 times y. Cross product here, 8 times 8. And in this particular case, I can't simplify that further, so the simplified fraction answer would be 64 thirds. If I want to write that as a decimal, it'd be 21.3 repeating. 333, 333, 3333. All right, moving on. Please remember, if I ever go too fast for you, which I'm going to speed up a little bit here, that's the whole beauty of a video, is that you can stop, go back, hit pause, replay something at any time. That's the gorgeous thing about a video lesson. All right, so determine whether the triangles are similar. If they are similar, write a similarity statement. All right, remember that what we just did back here, front page, these are the reasons that I can say triangles are similar. These 3 guys right here. So in order to be able to say, yes, they're similar, I have to see that one of these is true. In this particular case, I don't see any side lengths at all. So there's no way I could be comparing side lengths. I'm pretty much going to have to use AA or it's not going to be true at all. And hang on one second, I'm going to change out my sheet. Okay, I wasn't loving the bleed through there. So here we go. All I can use is angles. So I'm going for AA. So I need to see if I have 2 pairs of congruent angles. Well, this is like that one that tricked us earlier. I see 85, I see 85, yeehaw. But then I see 45 and I see 50. I can't say, oh, that's it. Go home, they're not similar. Because I don't know what this angle is. What if it's 45? And or this one's 50. So I'm going to check. Remember that the interior angles of a triangle have to add up to 180. So I'm going to look at this smaller triangle. I'm going to say 180 minus 85 and minus 45. And what do you know? It is indeed 50. So yes, I do have 2 congruent angles. I have angles L and X that are both 85. And I have angle K and angle Z that are both 50. So these 2 triangles are similar by angle. Now let's make sure we can get the order of the names correct. I like to start with the one on the left and name it alphabetically. And that way, if you do it and I do it, then we should get the exact same thing. It's okay if you didn't do it that way. We'll talk about that in a second. So JKL. All right, so then I look at what does J go with. You can really write the first one any way you like. It's writing the second one where you have to be careful, and angle J is congruent to angle Y because this one would be 45. So Y has to be first. Angle K is congruent to angle Z. And angle L is congruent to angle X. This is a perfect example of the fact that the second one's not always in alphabetical order, even if the first one is. It's not about alphabetical order, it's about making sure things go together. So now, speaking of which, let's suppose you had written the first one in an opposite order, or in a different order. KLJ, LKJ, LJK, whatever. As long as you put J and Y in the same position, K and Z in the same position, and L and X in the same position. By same position, I mean like first letter, second letter, third letter. So if L was your first letter, then X should be the first letter in the other name. If Z was your second letter, well, it is mine. If Z was your third letter, then K should be the third letter in the other name. Okay? So that's what we need to pay attention to for our similarity statement. And remember, that's what this is. This is a similarity statement right here. And yes, these are similar, so I'm circling similar. Number 8, okay? Do you see any angles on there? No, I don't see any angles at all. And unlike number 9, I don't even see information that could tell me about angles. I see nothing related to angles here. So that means I'm not going to be able to use angle, angle, or side, angle, side. So my only hope is that this could be side, side, side. So I need to compare all 3 pairs of sides. Smallest to smallest, that's 6 to 8. Medium to medium, that's 9 to 12. Largest to largest, that's 12 to 15. All right, I'm going to compare these by changing them all to their reduced or simplified form. This is 3/4, and you can let the calculator do that for you if you'd like to. And this one, not 3/4. So these are not the same. Even though these are, you have to have all of your corresponding pairs of sides. All of them have to be the same ratio. That's what similarity is all about. Everything is proportional. Everything has the same ratio. These do not all have the same ratio. So these are not similar. And please notice, if they're not similar, I'm not about to write a similarity statement because that's what that says. It says they're similar. So don't write one of those if they're not similar. And we don't have a reason because they're not similar. All we can say is they're not similar. Number 9. Okay. Again, I don't have any information on side lengths here. I only have information about parallel. What does that tell me? I also have an X shape. X shape's always vertical angles there. So I know vertical angles. And then having parallel sides gives me alternate interior angles. So angle P and angle R are alternate interior angles. So our angles T and S, but I have enough already. I have 2 pairs of angles. So I have angle, angle, and I can say that these 2 triangles are similar. So I'm going to circle this. And now I'm going to go ahead and name the one on the left. Element O, P, Q, R, S, T. So P, Q, T. I like to put the first one in alphabetical order because if I do that and my students do that, then we have the exact same thing. Makes it easy to compare. But again, it's okay if you don't do that as long as you have the correct corresponding points in the correct places. Let me just be a little bit better, more clear with that after I finish this one. P, I have 2 arcs here. It goes with R, so here goes R. Q, these 2 are congruent, so there's the Q, and T goes with S. Now, that's what I mean. Like maybe you said SRQ here. That's fine. But if you say SRQ, third letter, first letter, second letter, then you would also have to say T, P, Q. S goes with T, R goes with P, Q goes with Q. So you just have to make sure you have the correct correspondence mentioned, or correspondence in terms of your order. Number 10. Here I have some sides and I have an angle. So maybe it's side, angle, side. Let's look. This side says, it's hard to see, it says 72, and so does this one. So that's an isosceles triangle. How fascinating. And this one is also isosceles. That's interesting because look at that. If this side over this side, 72 over 132, that definitely has the same proportion because it's the exact same numbers. So I do have 2 pairs of proportional sides. I do have 2 pairs of sides that have the same ratio. And this is the angle between them, this 34, and this is the angle between them, this 34. So I have a pair of congruent angles. So I have side, angle, side. On this one, PQR. On this one over here, P goes with S. Beyond that, you could do whatever you want because this is isosceles. So I could say SUT or STU because remember in an isosceles triangle, base angles are congruent. So those are going to be the same and these are going to be the same. So STU or SUT. There's a lot of possibilities there. Next up, practice on your own. Well, this would be a good time if you want to hit pause and try these. There aren't that many blanks here, but I would definitely try to find all the same things we found on the problems above here. Find out, can you tell if they're similar? If so, how? And then write your similarity statement if you can. So pause. And now I'm going to assume you've done any pausing you wanted to do and are ready to go on. Here we have just sides. So I can't do SAS and I can't do AA. So let's see if I can do SSS. Shortest side is, 54. So let me come down here. 54 over. Shortest side of this triangle is 117. Okay. Middle length is 60. Not the shortest, not the longest. The medium one here is 130. And the longest one of GEF is 78. Longest side of SRT is 169. So these are the fractions I'm comparing. Okay, another way that you can compare them, I could reduce all of these. I really do think that's the easiest way, and it gives me the similarity ratio. Because remember, the similarity ratio is just the ratio of the side lengths. So they should all have the same ratio, or else they wouldn't be similar. And whatever that ratio is, simplified form, is your similarity ratio. So here my similarity ratio is 6/13 if I go from this one to this one. If I were told, and you can be told the order to do it in, if it said find the similarity ratio from the largest triangle to the smallest, whatever they say before the 2, that goes on top. So the largest would go on top. So instead of 6/13, I'd have 13/6. Another option for comparing, we've already talked about using cross products to compare two fractions at one time. You can also change everything to a decimal. See if I can change my setting, make that a little bit easier here, to classic mode. So 54 divided by 117, there's a decimal. 60 divided by 130, there's a decimal. And 78 divided by 169, same decimal. Now here's what I wanted to point this out to you for. If you do it this way, it can't be something that just rounds to be the same decimal. It's not like one of them could be 0.461 and the other one could be 0.463, and you're like, that's okay, they both round to 0.46. No, it has to be literally identical. So every single decimal place that you can see on your calculator is identical. All of these digits are the same. If that's not the case, then that's not equality. They're not equal. This time, they are, though. So all of these are equal. So by SSS, these are similar. Similar by SSS. Like I said, I'm going to add some more information. The similarity ratio, we know, is 6/13 or 13/6, depending on how you do it. And triangle RST is congruent, or sorry, not congruent, is similar to. This is where it gets a little hard, when you don't have any angles to look at. So here's how I do it. You might do it a different way. R is my first letter, okay? R, let's look at the sides. I know that this is the smallest side, this is the shortest side, this is the longest side, and this is the medium side. R is where the shortest side meets the medium side. So let's come up here. Shortest side, medium side. So that means E goes with R. And there's the longest side. Okay, so E would be my first letter. Then in the big triangle, it goes from R to S. So if I go from R to S, I am traveling along the shortest side when I go from R to S. So up here, starting at E, I'm going to travel along the shortest side to get to my next point. So it's E to F. So E, F, G. So this one is alphabetical order, but you cannot count on that. Sometimes it is, sometimes it's not. Okay, number 12. I have 2 pairs of side lengths, not 3, and I do have a pair of congruent angles, my vertical angles. So I'm thinking maybe this is SAS, but it's not. Why not? Because 41/35 is not the same as 42/35. Those are not equal. So these are not similar. And if they're not similar, please don't write a similarity statement, because a similarity statement is a way of saying they are similar. Okay, and please don't write SAS, because we don't have SAS. That's what we were looking to see if we might have. That was the closest thing that appeared might be true, but it's not. All right, moving on. The triangles in each pair are similar. Find the missing length. Okay, number 13, PQR is similar to KLM. Okay, so that means that PQ, first 2 letters, goes with KL. So that tells me 36/6. 36 goes over 6. And then this is going to be my X. ML, last 2 letters here, goes with QR. Well, that's good, because that's what I need. So 36/6 equals QR over ML. equals x over 9. One thing to be careful about when you're setting up your proportion. Sometimes I'll see students go 36 over 6 equals 9 over x. If this fraction goes big triangle, small triangle, then this fraction needs to too. Go in the same order in terms of which triangle you started with. If we're going to do big triangle over small triangle for the PQ and KL, then you got to do big triangle over small triangle for the x and the 9. Let's go ahead and cross multiply to solve this. We're going to do the two cross products. One cross product is 6 times x. I'll go ahead and write that because that's 6x. The other cross product is 36 times 9. That's 324. I'm not going to hit clear. Next thing I need to do is get x alone, so I need to divide both sides by 6. Well, look, I already have this in my calculator. That's why I didn't hit clear, is because now I can just hit divided by 6, and I get 54, and that's my answer. X is 54, or QR is 54, really. So I probably should have written that. Sorry. Next up, number 14. All right. CDE is similar to CST. When I looked at this, I was like, oh, I wonder if that's SAS. We're not trying to find out if it is similar, though, so we don't care. We already know it's similar. They told me so. Okay? Be super careful about what goes together. Does the 126 go with the 36, or does it go with the 27? We have to make sure we check. So this is going to be my X. CE, that's first letter, last letter, goes with CT. So 126 goes with 27. So 126 over 27 equals this one over this one equals CD, which is X. What does CD go with? First two letters, CS. That's the 36. And now I'm ready to cross multiply. One cross product is 27 times X. The other one is 126 times 36. Ooh, that's big, right? 4,536. Okay? And then to get X alone, I'm going to divide both sides by 27. So I left it in the calculator, and I'm ready to just divide by 27. And I get X is 168. And in this case, I'll remember that it's not really X, it's CD. Find the missing length, and that's CD. All right, next up, one thing that I tell my students on problems like number 15 or problems like number 17 as well. Anytime you have two triangles and they are either adjoined, like right up next to each other, or overlapping, it's not a bad idea to at least consider drawing them separated. So I'm going to do that here. I'm going to pull these apart. All right, this is going to be the bigger one. A, D, C. There's an X right here. And then from A to C, that's all the way down here. So it's the 9 and the 3 put together. 9 plus 3 is 12. That's the bigger triangle. Let's look at the smaller triangle. A, E, B. This is a 5, and this is a 9. So this is what I have here. So the explain why triangle ABE is similar to triangle ACD. Oops, I forgot my right angle. Well, you can't use the X. You can't say, oh, this is side angle side, because we don't know what X is. So we can't use it to prove it's similar, because we're going to need to know it's similar in order to find that. But notice these both have an A. They have the same angle. Angle A is in both of them, so angle A is the same as itself. Reflexive property. So we have angle, angle. That's the Y. So that's my first part, is by angle, angle. Then find CD. Okay, so now I'm ready to set up a proportion because I know it's going to have to be true because the triangles are similar. So remember, similar triangles means all the side lengths have the same ratio, and that ratio is the same as the similarity ratio. So 12 over 9 is the same as X over 5, is the same as this one over this one. And if I find that ratio and reduce it, that's my similarity ratio. So in other words, 12 over 9 reduced is 4 over 3. So that's my similarity ratio. 12 over 9 equals x over 5. If you wanted to, you could reduce that now and write 4 over 3 equals x over 5, because they're all the same ratio. They're all equal to that similarity ratio. I'm not going to worry about that because 12 over 9 is not a big unwieldy fraction or something. I'm going to cross multiply. One cross product, there's the other cross product. Remember, the key idea is they have to be equal to each other. 9 times x has to be equal to 12 times 5. 12 times 5 is 60. So I'm going to divide both sides by 9 here. And that goes, I believe, what is that, 6 2/3? Let's go ahead and let the calculator simplify it for us. We could just leave it as I don't really love mixed numbers. I was actually just telling my students that today. So why that's what popped into my head is beyond me. Well, I forgot to change the mode. Let's go back to the fraction happy mode. And 60 over 9. Okay, I'll change it back. There we go. 20/3. So I could just leave it as 20/3. There's nothing wrong with that. If you want to write 18.6 repeating, you're welcome to. Not 18. 6 and 6 repeating. Six times. I was thinking 3 times 6 is 18. So 6.6 repeating. But 20 over 3 is a perfectly acceptable answer. There's nothing wrong with that answer. Number 16. On a sunny day, you are standing in front of BHS. How much you want to bet the high school where I teach is called BHS, right? Okay. A friend measures the length of your shadow. It's 4 feet long. She also measures the length of the shadow of the flagpole, and it's 29 feet long. If, missing words, if you are 5.5 feet tall, what's the height of the flagpole? So, oh, there they are. Hi, if you are. All right, so these triangles are already drawing the picture for me. So the fact that it's a word problem, honestly, is irrelevant if it's already all been filled in on the picture for you. So we just have another similarity problem where we have two triangles. When it is a height problem like this, sorry, my triangles are not the best there. When it's a height problem like this, you can assume that the person or the flagpole that they really are vertical, meaning they are perpendicular to the ground. We're not standing on a hill or anything. It's a flat ground and a vertical flagpole or person. Okay, so I'm ready to set up a proportion. So I'm going to say 4 over 29 equals 5.5 over x. You could do a proportion many different ways for this or for anything. The key thing, if you set up your proportion one way and I set it up a different way, do you want to know how to tell if yours is still correct? See if you get the same cross products I do. If when you cross multiply, you get 4 times x and 5.5 times 29, then you're right. We've both set up a good proportion, even if they don't look the same. If you cross multiply and you're doing like 4 times 5.5 or 4 times 29, we got problems. So as long as your cross product turns out to be the same thing my cross product turns out to be, we're good. 29 times 5.5 gives me 159.5. Then I'm going to get x by itself, and that gives me 39.875, and I believe that was feet. That's the height of the flagpole. All right, number 17 is another one where I said this is an example of one that I would personally pull these triangles apart. Okay, let's look at one triangle is QPR. All right, what can I say about QPR? Well, I know it's got 60 for QP. What about QR? From Q to R is the 40 part plus the 60 part. 40 plus 60 is 100. So this whole thing is 100. Then I've got this smaller triangle, slightly smaller. I didn't draw it so well, sorry. UTV. Remember, it doesn't really matter as much what it looks like as the information on it, as long as you're not making judgments with your eyes. Don't do that in geometry. You look at the numbers and the measurements and the congruence markings, not the way it looks. So UV here, from U to V, is 60 plus 20, which is 80. They want the length of TU, so this is going to be my X. We also know that angle Q and angle U, these two, are congruent, and that angle R and angle V are marked congruent as well, these two right here. So by angle, I know that these two triangles are similar because they have two pairs of congruent triangles. Congruent angles. Then I can go ahead and set up a proportion. I can say maybe 60 over X equals 100 over 80. And then I can cross multiply. When I do that, I get 100X equals 4,800, I believe. And X is going to be equal to 48 when you divide both sides by 100. So there's number 17. Finally, we have number 18. Okay, number 18 says which dimensions guarantee that these are similar. So this is a little bit of a different one. Okay, this is a little bit more, I don't know, looking at it from a different angle. It's not necessarily that much harder, but you got to think about it differently. Okay. One thing that I know about proportions, and I'm going to go back to this. Everything being proportional, not only does it mean what I wrote here, okay, 2 over 5 equals 4 over 10 equals, where I'm taking one side from one triangle and one side from another triangle. Not only does it mean that, it also means if I compare two sides of the same triangle and then compare the corresponding two sides of another triangle, I get the same ratio there too. In other words, 4 over 2 equals 10 over 5. Or 2 over 5 equals 5 over 12.5. So you can also compare that way, and that's what I'm going to do here. I'm going to say, well, I know BC is 42, and I know CD is 58. So that's a ratio I can use to compare. So BC over CD is 42 over 58. BC and CD. Okay, BC is the first two letters, so that would go with FG. CD is the last two letters, so that would go with GH. So I need FG over GH to have this same ratio. Well, let me see what that ratio is. Let me simplify it. Okay. Or in this case, well, I don't know. There's different ways to do it. I was going to say it might be easier to do it as a decimal on this one. Let's just see. This gives me 21 over 29. So FG over GH has to be equal to that ratio, which means it has to be equal to 21 over 29. So this number, FG is the first one here on all of these, and GH is the second. So first over second has to be 21 over 29. First thing I notice about that, 21 is smaller than 29. So the FG is smaller than GH. FG has to be smaller than GH, that rules out A. FG has to be smaller than GH, also rules out C. So it's either B or D. So I'm going to set up a proportion for B. I'm going to do 12 over 14. And that gets me 6 over 7. Now let's look at D. 10.5 over 14.5. And it gives me not a fraction. On this type of calculator, the easy way to fix that is just hit this button right here. And I get, voila, 21 over 29, the same thing I need to get. So it is D. I hope this has helped. I know it's kind of long. Obviously, you probably have jumped around and used what you needed from here at this point. And if not, thanks for sticking with me. And I will see you next time. Bye-bye.